Okay, so we have already seen the method and tools to access, set, and modify values in NumPy arrays. Okay? For example, indexing, slicing, masking, fancy indexing, everything. The NumPy array is very secure. Okay? How do we do similar kind of things in pandas? Okay? Pandas and considerable method. Okay, here we'll see similar means of accessing and modifying data or values in pandas data frame objects. Okay? So how do we do data selection in series, for example? Okay. So first thing, I think we did a few of these. Okay. So let's just copy this. Okay. All right. So let me copy this one, paste here. So here's my data. Here's my series. So this is a series. Okay. Yeah, you're a series बनायो. So and then we have this series. Okay. And then okay, so this is a series. So we can use a dictionary like, Python expressions and methods to examine the keys and value, key indices and values. Okay, so for example, we can do all of these that we can do in a dictionary. A dictionary same thing you can do in series, right? So for example, we can do data. Uh, okay, so we can see, for example, if a particular, just the dictionary method, you can check whether a particular key is there or not. Say C. Right? You see there, okay, C as is my C is the index file. C in data, right? Of course, it's going to give us true. And as a figure, if I do say R in data, no, it's not there. It's false. Okay, so you say dictionary syntax. So dictionary one, right? Same kind of syntax. We can same kind of code we can use here. Okay, for membership operator like, right? अनि त्यस्तै गरी okay, so त्यस्तै गरी we can do we can get all the keys, right? We can get all the keys like that. सबै keysहरु आयो है. Keys गर्यो भने keys भनेको यसमा पाइथनमा सरी डिक्सनरीमा जुन keysहरु हुन्छ यसमा चाहिँ के हुन्छ भन्दाखेरि यसमा चाहिँ these are indices, है, indexहरु आउँछ. Like keys भनेको index, right? Okay, and then likewise we can do items, data.items. Okay, so we can do data.items. Right? If we do this, let's say it's a zip, right? Zip so rather it's like हामीले cast to 100%. You can cast to like say tuples, whatever you say. Rather, you can do an list, right? List हामीले let's cast it to tuple and you can see there. Okay, so let's see if somebody is waiting here. Yeah. Okay, so we can use dictionary like syntax. Okay, so likewise, series objects can be modified with a dictionary like syntax. Okay, very simple. A dictionary must go into the state. We can do, so for example, I want to this is our data. So I want to say convert or update C to say 5. Let's see C like 5. Let's see. All I need to do is what data, and give the just like in a dictionary, is equal to say 99. Okay, for example. So if I do data, so you see it's 99 there. Right there. Okay, so very much like a dictionary. Okay, so now, okay, so the series is a one-dimensional array, right? One-dimensional array group you can do slicing and everything. One-dimensional array. Okay, we have already seen this anyway, right? So let's not spend too much time on this. Let's say I want to do, let's say, B the key, B the key. I want B the C, B as so, or let's do this colon C, got it. Okay, भनेपछि के आउँछ? So what's the result?
0.25, 0.5099.
That's correct. Thank you. भनेपछि A B C मात्रै आयो है, C सम्म आउँछ. Startingदेखि C सम्म. Very good. Thank you. है. Okay, so you can do all this. See, जस्तै तपाईको numpy arrayमा जुन हुन्छ नि, you can do the same thing. Okay? So यो भयो. We can do all these. यो masking पनि गर्न मिल्यो. Masking, for example. So data that is data, yeah, data is greater than, so I want greater than, say, 0.5. यति मात्रै गरौँ. So यो गर्यो भने के दिन्छ? So it's a false, true, there. Means, okay, so let's do it over here. So this is my data. Okay, so if I do, for example, data greater than 0.5, गर्यो भने के आउँछ? So your first A मा false छ, B मा false छ, C र D चाहिँ true because they are above, like greater than 0.5. That's why you get true. Right? Obviously, like I want to get the actual data. All I need to do is data greater than, like 0.5 and, right? And we can do, of course, this data greater than 0.5 and less than, say, less than or equal to 1. So greater than, and we need to do what? Data less than or equal to 1, right? 1. Like so we can see that there's only 1, which is you must satisfy, right? All right, or you can see that in first one there is this this one, and here's the data. So so यहाँबाट यो चाहिँ के भयो? यसले चाहिँ हामीले मास्क दिन्छ, बुलियन मास्क, अनि त्यसपछि त्यही मास्क चाहिँ एज अ फ्यान्सी इन्डेक्सिङ युज गरिरहेछ. Okay, all right, so this also helps. Yeah, it also makes sense. So you can do pretty much use the syntax just like in a one-dimensional array, right? Okay, so you can do fancy indexing, of course. Fancy indexing on a million. So fancy indexing now, of course, you can do data. I want data for data. Fancy indexing फेरि अर्को एउटा things, हैन? So मलाई B र D को मात्रै चाहियो. So I can do B, comma D. Okay, see, I got B or D. Okay, because this is what? This is fancy indexing. Okay, so these are pretty much, okay. So you guys are pretty have looked at, accessing, manipulating data in a series extensively. Now there's something called LOC and ILOC, right? LOC or ILOC, okay, they're very important, right? So let's talk about them. LOC and ILOC, what are they? Right? So in your LOC or ILOC, we have two indices, right? We can have explicit indexing and implicit indexing. The way on a subset, right? So dubai chop, of course, like in a series or a data frame, we have both of them. So sometimes it's ambiguous. Let's take this example. Your example. Now this is ambiguous. You see, it's the problem, because it's clear that one ABCD similarly, data one it's of course implicit because it's explicit one minute. It's fine again, right? So what in this case, like something like this? Yes, I'm saying It's my data set. So this is my series. I used to have a series. I use series much. Now if I do 135 these are explicit index. 135. It's implicit, yeah, implicit x implicit index Q. What is the implicit index of x?
1
0.
0.
Zero, of course.
Zero.
Implicit saying 0 by explicit saying
1
1. है त्यस्तै गरी यसको implicit के भयो
1
1 भयो explicit 3 भयो and so on. Okay, so if I do say for example data मैले data 0 गरेँ भनेपछि अब यसलाई हैन so see error आउँछ नि त है किनभने it doesn't know whether it's what do I mean है okay, so it's not clear है so यस्तो छ अब मैले data 0 गरेँ भने त अथवा data 1 तर यहाँ त अब ambiguous छ नि त and what do I mean so त्यस्तो केसमा हामीले के भन्छ भन्दाखेरि we can use LOC or ILOC हैन so यसमा के भन्छ भन्दाखेरि ILOC भने यसले चाहिँ के जनाउँछ भन्दाखेरि this is implicit indexing है यो implicit युज गर भनेको implicit है अनि त्यसपछि LOC चाहिँ explicit so now अब ambiguity जान्छ है we can make it you know unambiguous कसरी भन्दाखेरि you can do data so if I mean to use implicit index I can do data.iloc हैन अनि त्यसपछि I can give my index right जस्तै iloc मैले 1 दियो भने के आउँछ होला
y
3y 3y okay y yeah thank you y yes okay all right very good okay all right likewise if I do the same if I do LOC1 अब चाहिँ के हुन्छ
x
x very good hey understand because ILOC1 भनेपछि I भनेपछि implicit भयो implicit भनेपछि 1 भनेको यो भयो हैन यो वाला भयो okay so अनि LOC भनेपछि explicit भयो explicit 1 भनेको यो चाहिँ index भयो which is x right है त so value x आयो see so always so it's better to use you know just यस्तो केसमा especially when your explicit index is an integer right when explicit index नै integer छ भने चाहिँ then always go with you need to use iloc or loc right? Otherwise it's arbitrary okay so that's how iloc and loc works so let's see okay we have already done this okay it's company of course you can do slicing and everything so I don't have to show each one of this I forgot right there it's the LOC1 so you range पनि गर्न मिल्छ right so you can do all this kind of range and everything iloc पनि same thing right so I will show each of them you can try them right it's in the notes right okay now data selection in a data frame data frame data frame is two-dimensional data structure right data frame acts in many ways is two-dimensional or structure right or a dictionary of series sharing the same index right so let's see he's okay you're using let's do this let's create these two area and then we have this population area populations okay so now if I do let's see area and population okay all right so here are two series hey this series they are a series and then they share the same index the index is same okay California Texas New York Florida Illinois same thing as so and then these are two series right? These are two series so we can create a data frame out of these two series hey the data series whatever a data frame so we can do rather let's use the same okay data is equal to pd dot data frame right? Okay, and then we can do we can pass a dictionary, a dictionary format. We can give the name of the column, So area name, right? Column, the dictionary, and then the series, right? The series area when the series. Okay, and this thing already we can do population. Population बनने नाम दियो त्यो column को column and this population series, right? So if we do these, right? So this is our data, understand? So here is our data. So this is a data frame, right? Okay, this is a data frame. Okay, so now once you have that, okay, now just like in a dictionary style, right? Dictionary style. So if I do again, this is my data. So if I do data, right, population, okay, so data population, so I can access the whole series. Like series thing, right? So this is going to be a series, right? When we are just accessing one or subsetting one column, you're a column at the okay, this is only one column, right? Okay, so likewise, okay, just give me a second. All right, so now, okay, so this area we can subset this area is my area material, okay? The area population new area. So this is if you do type. So type निकाल्यो क्या हुन्छ? What is the type? क्या हुन्छ? Series, very good. It's a series. Okay, so now likewise, okay, another thing, है त मैले यसैलाई मैले very conveniently यसरी पनि गर्न सकिन्छ. Data dot it's the area. Right? Same thing. It's the same thing. So यसरी गर्दाखेरि के हुन्छ भन्दाखेरि तपाईको तर if you have any यो column name space so white space characters भने हुँदैन. यदि त्यस्तो स्पेसहरु छैन जस्तै एरिया अनि स्पेस समथिङ त्यस्तो छ भने चाहिँ हुँदैन है फेरि. त्यसमा हामीले we need to use this notation. है यसरी नै गर्नुपर्छ है. यदि तपाईको उसमा column name मा स्पेसहरु केही छैन so white space characters छैन भने चाहिँ we can do it directly like that. है dot notation मा गर्न मिल्छ है. All right, so another very cool thing, say I want to get the density, right? Density निकाल्नु पर्यो. Very simple, sir. So I can do data, just like a dictionary syntax, right? So density is equal to density, population density formula Q. What is the formula? Population density area, okay? Population divided by area. Population, right?
Population divided by area.
Right. Okay. See, okay, very good. Okay. If I do this, then okay, so now I have density and all these. Okay, so these ones are required. Ready? So population divided your 38 divided by 424, 26 divided by 696, and so on. All right. Okay, so now, okay. So now data frame as a two-dimensional array. Okay? Data frame can also be viewed as a two-dimensional array. Okay? So data.values. Okay? So here it is. Okay? So your data sunny, your data ma. So you're using your scientific notation material. It's the same data, eh? Exact same. Now we're using values of the it gives you a two-dimensional array. You're a two-dimensional array means. You can see the exact same thing. Index same thing then. Just we're just accessing values. It's values are method, which is what 5 by 3. Okay, so likewise, okay, so you can transpose this. I just say about your slide. We can transpose this, transpose the data frame. Right? Transpose the figure near here. Of course, you can do data.g, but when transpose into see transpose y. Okay, so let's see why this is our data. Okay, data.transpose. Transpose when you pass in it, right? Okay, what is transpose?
Column like row like column.
Yes. Right? Rows or columns are row 1, 2. See, the columns or area density population in your they become rows. Right? Area population density, they become rows. And in ESCO California, you're saying rows are the units, those they become what? They become the columns. Okay. So so yes, and then we can do see data values 0. So again, data.value. So above you can do data.values. You can do a 0 or 1 it will give you that row. The row these your case second row here 1 minute second row here right here. This one right here. Okay, so likewise, let's see. All right, so of course, there's implicit indexing. You can do that. Okay. Data iLock. So I want to say is for a slicing to the combination. Okay. So data dot iLock. Implicit indexing is better. So CMD, I can, for example, I want rules or I can pick. So for example, you do the rules picker. You do that. You see, this key ones. You do that pick on you're slicing
column 4.
2 column 4 columns 4 0 1 4 yes right 2 column 4 2 column 4 and okay this is it that is same like I just want these 2 columns you do the columns here
1 column
1 column very good right?
1 column
right? So let's see 5. So that's what we want, right? So what I said is 2 4 and see 0 1 2. You did a column what? You did a column, but you see 2 column go last to the other column. You see 1.9 10 times 10 to the 1. This is 19. This is good. 1.34. Okay. Yeah, it's right here. Okay. And then yeah, take an episode. It's 20. Okay. And 0.117. Okay. So yeah, so we can do it that way. Okay. So explicit indexing, of course, you can use explicit indexing like that. Okay. And lock area, so we can use same thing using lock. Okay. So data dot lock LOC. And simply you can do same thing here as similar Texas to Florida. Say you can do Roma Texas, Florida some Florida this is the columns मलाई चाहिँ यो I want say population and density one. Population column density. So let's try that. So yeah, we got that. Right? Texas State, Florida, some population and density. Okay, so far so good. Okay. Okay, so okay, same thing we can do. You know, this combine masking and fancy indexing. Okay? Masking and fancy indexing. Say I want you know data dot data what data density data dot log data dot density is greater than let's see. So let's see, greater than 0.1. Okay. Greater than 0.1. 0.1 on the Matiko. Okay. And I want your wire and density. I can do that. And then let's just do this one first. Right? Please turn off your mic because the mic on beta. Please turn off your mic. Anilji, can you turn off your mic? Thank you. All right, so data density is greater than 0.1. Let's try this. Okay, so you can see there, right? Understand? So data density greater than 0.1. And this is a mask thing. So this is a mask, right? And this must have fancy index. That's okay. So you can see there it's the 0.1 greater than 0. Yo touch, yo touch, there's the 0.1. When the mathiko, you change 0.1 when the comes, right? So they are excluded, right? So as you can see there, right? So and then over ISMA saying I want to get only say area population, right? And let's see, I can do and ISMA saying area and population. Let's try this. Say area population मात्रै आयो नि है अब यहाँनिर fancy index भयो फेरि here's the fancy index. Okay, so now I hope it makes sense. Okay, now let's see. Okay, and then we can also update. Okay? Say I want to update. This is my data. Say I want to update my population to say like the Florida population maybe 22 or 99. Right? Florida population 99. And it would say I can use for example data dot iloc use right? iloc use the key you suggest similarly Florida population like 99. Any ideas?
So actually question
Okay. So Malay say Florida population say 99. I need to access this one using iloc. iloc but sorry you say row row ma say iloc gets index gets row ma you index got you. Yes, that's right. So row ma 3 ani yes 3 भयो अनि column ma कति छ
column
1
column 1 oh yes right you will say 1 भयो because you 0 भयो you say 1 1. What should I get?
20.
Good. Very good. Right? Obviously, if I do equal to 99, I was thinking about see, I 23 of 99, right? So I can do explicit indexing, but just like so. Let's try that. So this is my data. Say I want to now. I want to do this. Say I want to convert, or rather, make this 500. Right? California to 500 area 500 using lock. Okay, so we can do data.lock. Right? What should I do?
California.
Okay, very good. California. And this is comma
Area.
area. Okay. Area. You got it, 424 also is equal to say 500. Right? When we say now my DC now you 424 over 500. Right? Okay, so excellent. Okay. So now let's see. Yeah, boy. Okay. So these are things that you can do on your own, right? So you so I'll just skip that part, right? So yeah, you punya everybody right? So okay, so I'll just because it's in the notes. So okay, so operating on data is in pandas. Okay, so as you so far, do you have any questions so far, Dixon? So wait, say, okay. Okay, so now operating on data in pandas. So as you saw, NumPy has the ability to perform quick element-wise operations. This is arithmetic operations, as well as substituted operations. So So okay, let's see some of these. Okay, let's say NumPy array is my key to the idea. You know, you can do manipulation in NumPy array. So okay, so that's not you. This is data messed up with some data can be messed up. Okay, so say the my name was the row wise my order row wise sorting on column wise sorting on see independently on independently on so relation preserve model, right? So that might in the real world data the problem also is so numpy everything to say use got the it's error prone, right? There's potential for error, right? There's so but if you use pandas data frame, then you don't have to worry, right? It will make sure that everything is intact, everything there's no error introduced, right? So you'll see that in a moment what that means, right? So say unary pandas mechanism, like negation, trigonal function, the u function preserve indexing. This is the key part. The key part here, it preserves index and column levels in the output. For binary operation, addition, multiplication, automatically assigns indices when passing objects to u functions. Okay, let's quickly look at an example. Right? Say this is an example right here. Okay, so here it is. So here's my series. Okay, here's my series. Okay, and then, or rather, Melissa will say, I'll stop right here, and then please join right after this. And